All right, ladies and gentlemen, good afternoon. It is certainly nice to see you guys. I want to go to my website to direct you guys to what you want to look for today. A couple of things here. We're going to look at hypothesis testing still, but this time we're going to use a very similar method to what we used last time. This is going to be called the p-value method. Okay, it's the modern method. And so, let me go to my notes here and try to go to where we left off here. Okay. And let me go through this. And I have to find p-value method, modern method. Actually, let's download it here for ourselves. For this class here, hypothesis testing. Okay. We'll enter it in Notability. Let's remember, what's your guys, this is fall 2023. What section are you guys again? Section 1, 3. What is that? So you guys know what section you're in?
408.
I think it's 408. Let me double check. Yeah, 16408. Okay, so we're still going to work with our hypothesis testing. P-value, section 16408. So I'm going to work with the modern method, okay? So here we're going to go through the same concept we did before. However, this is our criteria that we're going to look for. Okay, we're going to look for, again, this p-value. And that's a probability value. And we have to have this probability value to be less than our level of significance alpha. All right, so remember, alpha was that level of significance. So I'm saying here, with hypothesis testing, this is where we left off. We can compute a p-value instead of the traditional method, looking for the test statistic value, and we want it to be less than our level of significance alpha. If we do that, we can say that we have found statistical evidence in favor of the alternate hypothesis. Now, here's what we really want to know. If we have this statement here, then essentially we say the p-value is low. So this is saying that your p-value is low if it's less than the net level of significance. If the p-value is low, we say the null has to what? Go. Okay, it's an if-then statement. If your p-value is low, how low? Smaller than the level of significance, then the null has to go. Okay, so this is going to be the modern method. This makes things a little bit more efficient, and we're going to actually go through what this means. Now, alpha can be, ladies and gentlemen, various percentages. It could be 1% or 5% or 10%. These are the typical alpha values. And you say, what is alpha? Well, it's the level of significance. It is the borderline chance used for making a statistical decision. Okay, so the p-value tells us the probability of obtaining a test statistic that we observe based on our sample, assuming that the null hypothesis is correct. So essentially we assume the null is correct, and if it's smaller than the level of significance, well, then we are, you know, what? We have to say, guess what? It's not happening. The null has to go. Anyway, let's go over some details here. All right, we're going to do some details here. And yes, in your notes, we have what's called these errors here. And let's do something as well. I think I have to put that in the chat. Does anybody here look at this stuff here? Anybody watch it at home? All right, well, there you go. So it's going to be in the comment section, okay? So we're going to go through an example, and I think the example I want to do is something like this, okay? Here's my first example of the modern method. This is going to be a hypothesis testing about a what? About a proportion. Do you guys remember where we left off? Hypothesis testing? All right, so let's read what it says now. It's saying that the proportion of college students who have a Netflix account is what? Well, it's less than what? 75%. Yes, and that is the claim by good old who? By good old Snodgrass, okay? So let's go through this and say again, remember, P is your proportion. So when you translate this, you say P is less than what? 0.75. And again, this is the what? This is the claim. So this is how we start the process. Now, do you guys remember last time, right? Where does that claim go? Is that a null or is that an alternate? You actually see it right here. That's going to be an alternate hypothesis, ladies and gentlemen. Usually I move this around and I say, hey, that goes down here in the alternate hypothesis position. You say, why? Because it lacks the condition of equality. So what we were working with last time, and I have the notes, if you have the less than as the alternate hypothesis, that will tell you always have a what? A left tail test. You guys remember that? So we were looking at the traditional method last time. Today we're going to do a modern method. And notice this, even though we're not doing the traditional method, this is a left tail test. You get your 1% alpha, because I guess they're telling us alpha is what? There it is, 1%. So sure enough, it is here. This is the decision rule, but you really don't need a decision rule. And yes, you would have to get the critical value using, again, inverse norm. So I'm just going through this traditional method. However, today we're going to use the what? The modern method. So I did go through the information here. And okay, let's share with you guys how you really do this, okay? So make sure you gather your sample information. And what does it say about your sample, right? It says what? A sample of what? 350 college students reveal 288 have a Netflix account. That's from a sample. So what does this actually mean if I say to you guys that there's a sample of 350 college students? What does that mean? Yeah, that's a sample size. Good, thank you. Outstanding. Your sample size is what? N, 350. And of the 350, how many have a Netflix account? So that's X, 288. So, ladies and gentlemen, there you go. Okay? So we're getting all the information we need in this hypothesis test. I think this is your first example, really, of what we have called a left tail test. This is why I want to go through it. Now, does anybody remember, I know it's been about a week, What other information is so important to do by this traditional method? I think you need something. What else do you guys need? Do you remember this? You guys need a mu, I'm sorry, not a mu, a what? A P naught. What's the P naught value? Does anybody remember from last time? Where is P naught? P naught is the proportion in the null hypothesis. So you have to find the null hypothesis. It's right there. And P naught will be 0.75, okay? So that's your P naught. It's going to be 0.75. So, ladies and gentlemen, you have everything you need right here, because in the TI calculator, what command do you guys use? We use what? What's the command? Good. One proportion z-test. Outstanding, ladies and gentlemen. So one proportion z-test. Now, in the notes, I have all the information for you guys. One proportion z-test. Now, you might say, why is that a z-test? Because you're using the standard normal distribution right over here. That's what the z stands for. And why is it one proportion? Well, because this is a hypothesis test about a what? Proportion. There's one proportion. So in the TI, that's the one proportion what? Z-test. Now here's what I'm going to do for you guys here, right? We're going to go to the TI calculator. We're going to go to, remember, stat, and all your tests are over here, stat test. We're using one proportion z-test. Where is that? Isn't that number 5? Okay, so I want you guys to get number 5 there in your calculator. Now, notice what you have to put in. What's the first entry? Isn't it P naught? So P naught was 0.75. You guys okay with that? How many successes were there? 288. What's your sample size? 350. Okay, you guys okay with that? And then, what kind of test is this? This tells you right in here what kind of test you guys have to indicate. If it's not equal, you say, what do you mean not equal? Go back and remember, why is this a left tail test? Because in purple, your inequality there for the alternate hypothesis points to the left. So you have a left tail test. So in your calculator, make sure you put what? How do you get to the left tail? Go to, it's the second one here. Hit enter. That tells the calculator this is a left tail. So you want to point it to the left, okay? You guys okay with that? Anybody have any questions on that part? You just now hit what? Calculate, and guess what, ladies and gentlemen? We're looking for what's called the p-value. Where is that p-value? Well, it's the third line, okay? It's p. And if you go to the thousands position, I even have it on your notes. It's this third line right here. That's the p-value. Your p-value is approximately what? 0.99 what? 9. Okay, can you guys see that there? That's your p-value. You don't need the z-value. You don't need a decision rule with a modern method. You just need the p-value for the modern method, okay? All right. Good enough, good enough. Okay, so I'm writing that down here. There we go. Now, remember what you have to check. You need to check if that p-value is smaller than the level of significance. I think it's 1%. Was that 1%? Did you guys remember alpha? Alpha is what here? We didn't even write it down, did we? Here's your alpha. Alpha is what? 1%. Here's my alpha. You say, how do I know? They're going to tell you. So that p-value and that's what I'm writing down here. Your p-value is going to be actually point what? It's almost 1. So this is not the case that this number, 0.999, is not smaller than the level of significance of 1% here. Okay? So in other words, the p-value is not low. If the p-value is not low, then you automatically do what? You accept the null hypothesis. And what I've been telling you the last class, you do what? You keep the what? You keep the null. So this is the probability value that the null is valid. So your p-value this is almost certain. Is that right? Isn't that close to 1? So this is almost certain. It is almost certain that your null is what? Valid. That's the p-value. The p-value is the probability the null is valid. So if it's almost certain to be valid, you're going to keep it, okay? So this is an example here. So if we say, okay, we keep the null, go back to the null, and you say, okay, here's the null. I get to keep the null. So if I'm going to keep the null here, H naught, I'm going to hug it. That's a hug. Okay, I know you can't see it, but let me try to make it a better hug. We're keeping the null. However, what does that mean about the claim if we keep the null? Do you guys know? What does that mean? Do you guys remember from last time? We're keeping the null. There's only 2 kinds of conclusions we can say. Either the sample supports the claim or the sample does not support the claim. So if you're keeping the null, what's going on to the alternate? Your alternate is gone, ladies and gentlemen. When you keep the null, you get rid of that alternate. What did you really get rid of? Where is the claim? The claim is right here. So keeping the null means you got rid of the claim. What do you think that means? That means the sample, what? Does not support the claim. So your sample does not support the claim, ladies and gentlemen, very simply because we got rid of it. So the proportion is at least 75%. And this means we no longer, for the modern method, have to create a decision rule where you need to find critical values. So the modern method that I just showed you guys, the p-value method, is actually the really preferred method in science. And in the notes, I even have it here. I say what? Sample does not support the claim. So this is an example of the p-value what method. What do you guys think? Do you guys prefer it? Okay. Let's give you guys another example. What do you guys think? In the notes, I have another example for you guys. It's a right-tail test. Let me show you guys why. Okay, so in our notes, what do we say here? Let's read this here. All right, we're saying the what? The proportion of college students who get a good night's sleep the night before a final exam is what? What does that say? No more than 33% as what? Claimed by Snodgrass. All right, okay. So this is P for proportion, okay? What is no more than? You guys know what no more than is? Isn't that less than or equal? No more than, that's the limit. It's 33% or less. So we put here no more than. That's less than or equal to, and 33% is point what? 33. That is your what? Claim. So what kind of hypothesis is this, ladies and gentlemen? Is that a null or is that an alternate? It's a null. You say, why? I put that in the null position because it has a condition of what? Equality. Good. Because remember, we have to check that. And that's why it's in the null position, because it has a condition of equality for no more than. So what that means now is the opposite of the statement there of less than or equal is going to be greater than. That means the alternate hypothesis is a greater than. What direction does that inequality point? That points where? Isn't that, we're looking again, what defines the test? The direction of the null hypothesis, and that points to the right. It's a right-tailed test. Now, what kind of method are we using again? P-value. So what that means is I got to go back and read my sample information. What does it say? Sample of what? 500 college students reveal that 125, I'm going to get rid of this, 125 get a good night's sleep to find at least 8 hours the night before a test. So when I write my sample information down by this modern method, what do I want to write down? I want to write down what? Sample size is 500. The number of successes is what? 125. Let's see if you guys remember. What's P naught? P naught is what? The proportion in the null hypothesis. So if it's less than or equal to P naught, then equals 33% here. And this is again a right what? Tail test. This is all the information we need if I can, there we go. It's all the information we need. Don't forget, what's your level of significance? This time alpha is 10%. So it's not as sensitive. Okay, so this is the alpha. Alpha equal to 0.10. What's the command of the TI? Because by the modern method, we don't need this decision rule. By the p-value method, we don't need that. So we have to enter, what's this again? 1 proportion z-test. So let me share with you guys again here. And the TI. We go to stat, test. Number 5, isn't that 1 proportion z-test? It sure is. What's your P naught? 0.33. How many successes? 125. What's the sample size? Is this a right-tailed test? Make sure that inequality points to the right. Hit what? Calculate. And what do you end up with? Wow, look at that number. If you had to go to the thousands, what's the problem? Yeah, what is this? It's like 1. You're right. So even in my notes, I put that p-value right in here. And that p-value, ladies and gentlemen, is really approximately 1. And you might say, can I put 1.000 to the thousands? And that's 1, yes. Now, this is the probability that the null hypothesis is valid. So if you're approximately 1, It's almost certain. Remember those probabilities? Probability of being close to 1, that's what P is. It's a probability value. That's a probability that the null is valid. That's close to 1. So I guess that means we got to keep the null. Is that true? Notice what I have here. You just have to check. Is the p-value smaller than alpha? Is 1 less than that 10%? Okay. P-value is 1. Alpha is 10%. Is that true? What do you guys think? I'm going to put more information. Is $1 less than 10%? Nope. So what does that mean? You keep the what? We keep the null. And when you keep the null, I have it down here just so you guys know, we're going to hug the null. We get rid of the what? Alternate. What just happened to your claim? Do you guys want to tell me what happened to your claim? You're hugging the claim, and that means what? Yep, sample supports the claim. There you guys go. That's your p-value method. What do you guys think? You prefer it? Maybe. No decision rule, no critical values, no bell. You just check the p-value is less than alpha. If it is, you reject the null. If it's not, you keep the null. Easy peasy lemon squeezy. Let me give you guys an example here. Let's have you guys try one here, okay? Let's see if you guys are awake. I'm going to go through my notes. Let me find this here. I'm going to say this here. I'm going to call this modern method. Modern method is the p-value, and then you guys are section 1.6 what? 1.6, is it 408? What's your section? You guys are section 16408, yeah. Okay. I'm gonna have you guys try this, okay? Here we go. See if you're awake here. The proportion of college students who have a high IQ, okay, is 25%. As claimed by what? Snodgrass. A sample of 250 what? College students reveal that let's say what? 28 have a what? High IQ. Now, in reality, they would have to define high IQ. Use the 5% level of significance to do what? to test this what? Claim, ladies and gentlemen. So I'm going to give you guys, and you're going to use what method? Yep. You're going to use the p-value method, which is called the modern method, the one we just described. Okay? We'll give you guys some time to try this out. We're going to link together what we just talked about with, what we just did here. So I'm going to give you the lucky number 7 or lucky 8. Try this out, ladies and gentlemen. Use the p-value method. Let's see what happens. Okay, let's try this out. You guys ready? Let's read this. What does it say here? The proportion of college students who have a high IQ is what? 25%. As what? Claimed by who? Snodgrass, okay? So, what do you guys write down? What does that mean, right? Isn't is short for is equal to? So you're going to write P equals 25%. And this is the what? Claim. Is that true? Okay, now where does that go? Is that a null hypothesis? Or is that an alternate hypothesis? Where do you put this here? Is this a null or an alternate? Null or alternate? Which one is it? Condition of equality makes that a null. Is that true? Okay, what's the logical opposite of equal? Not equal. And the second you guys see this, what does that tell you about your test? What kind of test is this? You guys want to tell me? If it's a not equal, if the alternate hypothesis is not equal, what kind of test is that? Anybody remember? What kind of test if it's not equal? Yep, always. It's a two-tail test. Good job. All right, good. Okay, anybody have any questions on this so far? Right? This is your hypothesis setup, okay? All right, now let's read. What does it say if we read? It says what? A sample of 250 college students reveal that 28 have a high IQ. Now, what does that mean? A sample of 250. 250 represents your what? Sample size, and then what does the 28 represent? Your successes? So write that down. You're going to punch this in the TI. So your sample size is 250, and then the number of successes is 28. You always need, what number is this? What do we call that, ladies and gentlemen? P what? P naught. The proportion in the null hypothesis, P naught. P equals that value, so here's our P naught value. P naught is 0.25. All right. We're going to use our what? TI calculator. What do you guys use in the TI? 1 proportion Z what? Test. Alpha, what did they tell us alpha is? 5%.
0.05.
Mm-hmm. That's 5%. Okay. P-value method has us check if P is less than alpha. If it is, the null is too low and it has to go. Okay. So we go to stat, we go to test. 1 proportion what? Z-test. Okay. P naught point what? 25. What is X? 28. What is N? 250. Okay. What kind of test is this? Yes, it's a two-tailed test. Is that right? So hit the not equal when it's a two-tailed test. Double check. Isn't that everything that we have here, all the information? Okay, then let's hit what? Let's go down to calculate. Looks like we're good. Now, ladies and gentlemen, you got to be careful with this one. What do I mean by that? Do you guys happen to know what the p-value is? It's very near 0. How do you guys know? You say, I'm going to write down 1.4686, but don't forget you get this e to the minus what? 7. So let's talk about what this means. You guys remember what that meant? This here, this is scientific notation. That's like saying times 10 to the negative 7. What they want you to do is take the decimal and move it where? 7 spaces. 1, 2. 7 spaces to the left. 1, 2, 3, 4, 5, 6, and 7. What do you do with the blank spaces?
Zeros.
So you get 1, 2, 3, 4, 5, 6 zeros, and then now this would be what? 1, 2, 3. You know what your p-value is approximately? What is p? It's approximately 0. So your p-value is approximately 0. Is that, what is your alpha? Is that smaller than 5%? Say what? It sure is. Isn't it smaller than 5%? So, ladies and gentlemen, the p-value is smaller than, that's actually close to 0. What does that mean again? The p-value is what? Low. What does that mean? The null has to what? Go. So whenever that p-value is less than alpha, the null has to go. So when I go to the null, you say, okay, no. You got to go. You're what? You're gone. So if the null is gone, you have to accept the alternate. Okay? If the p-value is low, the null goes. What does that mean? Oops. I don't know. What does that mean, ladies and gentlemen? If the p-value is low, the null has to go. What does that mean about your claim? Where is your claim? Your claim happened to be in the null hypothesis position. So that means the claim is gone. The conclusion is what? The sample what? Does not, you're right, support what? The what? Claim. The sample does not support the claim. Sample does not support the what? Claim. Look at all that, ladies and gentlemen. What do you guys think? Is that easy peasy, lemon squeezy? Okay.